Right, continuing with simplifying exponential expressions, let's have a look at one more, let's say, big, complicated one, and then maybe a series of smaller ones. I'm looking at this one here. I'm looking at x to the power 4. Wow, I did not mean to start with pink, but alright. X to the power 4, y to the negative 3, z cubed times negative 2, x times y to the negative 1, all of this divided by 2 y raised to 4 z cubed. By the way, this is a z and that's a 2, not that there's any confusion. All of this raised to 4. Now, one of the things that I can do with this, since it's all multiplication, is that I can move things around, rearrange stuff as I please, and I will do that without sort of making anything illegal. So the first thing I like to do is I like to collect all my numbers in front and all my variables at the back. So this is just simply negative 2 in front here. Then let me collect all my x's together. I have an x raised to 4 times x, right? This x here. Let me collect all my y's together. Y raised to negative 3 times y raised to negative 1. What else have I got? I've got a z on it. So that's a z cubed. And down here, I'm just applying this rule because I have an exponent on the outside, so I have to distribute it evenly among all the factors. So this will be 2 raised to 4 times y raised to, there's a 4 and I'm raising it another 4, so this is going to be 16, right? Easy stuff. Times z, there's a 3, so z cubed, and I'm going to be raising it to 4, so it's going to be 3 times 4, which is 12. Let's quickly simplify what we have up there. This is negative 2, right? This x can be thought of as being x raised to 1, so I'm going to have x raised to 5, right? 4 plus 1, because if the base is the same, then the exponents simply get added together. Y raised to negative 4, right? Because we've got a negative 3 plus minus 1, which is negative 4, times z cubed. All of this, 2 raised to 4 is 16, divided by 16, y raised to 16, z raised to 12. Let's keep the numbers as they are. X raised to 5, y raised to negative 4 minus 16, do you agree? Because I have a 16 in the denominator, so when I bring it up, I'm going to have to subtract that exponent, times z raised to 3 minus 12. Again, the same reasoning. All of this divided by 16. I have a 16. Now let's quickly simplify. This 2 will cancel, I have a 1. This is 8. So I don't need to write the negative 1, right? It's just negative x raised to 5, y raised to negative 20, z raised to negative 9. All of this over 8, right? 3 minus 12 is negative 1. Yes, that's correct. And then, because I despise negative powers so much, I'm going to bring anything that has a negative power back down into the denominator. So this will just leave me with a minus 5, minus x raised to 5, sorry, over 8, y raised to 20, z raised to 9. And that's the answer. So like I said, if I have a very complicated looking expression like this, since it's all multiplication, I can move it around as I please. I can rearrange the terms as I please, and I should do them because I like to have all my x's, my y's, my z's together. That helps me. Alright, let's do a few more problems then. Let me just quickly clear my screen. Right, continuing. Let's look at a few really easy ones now. One of the other things I need to keep in mind is anything raised to 0 is 1, always 1. So since I have this, I can think of this x raised to 0 as being 1. So I have 1 squared times x raised to 4 over negative x squared. Again, z raised to 0 is also 1. Now, 1 raised to anything is always 1, because 1 squared is basically just 1 times 1, so it's just 1. I don't need to write it, right? 1 times, okay, I wrote it anyway. of that negative 1 times x squared, which is x raised to 4 over negative x squared. And like I said, if I have a stray negative just on the denominator, I can bring it back up to the numerator without any problem. So I have negative x raised to 4 over x squared. Oh, guess what? I have the same base and I'm dividing, so I simply need to subtract the exponents. That's going to be negative x raised to 4 minus 2, which is negative x squared. And it's literally that easy. Alright, moving on, let's do this slightly more complicated looking thing. Remember, anything raised to 0 is 1, so let me just take care of that first. X raised to 0 is just going to be 1, so I'm going to end up with simply 1, right? This is a 1. And 1 times, I don't need to write that. This y raised to 0, this is going to be a 1, right? And I'm left with these. Okay, so let's get about solving this. Let me change color just to make things interesting. So I have y raised to negative 3, all of this raised to 4, right? And down in the denominator, I should start collecting the like terms. So this is going to be x raised to negative 3 times negative, no, no bracket, negative x raised to negative 3, right? Y raised to 4, z raised to 3. Up here, this is going to be y raised to negative 12, right? Because of this rule here, where if an existing exponent is raised to another exponent, I simply multiply. So negative 3 times 4 is negative 12. Down here, the two x's multiplied, I have the same base, so I can add, right? But I have a negative in front, so I just make sure that I keep that consistent. So I have a negative x. And since I'm multiplying, I need to add the exponent. So negative 3 minus another 3 will give me minus 6, right? Y raised to 4. Z cubed. Now let's just quickly take care of the y, right? I have a y raised to minus 12 and a y raised to 4 in the denominator. So when I push this up, it's going to be a minus 4. So I'm going to end up with y raised to minus 16, because minus 12 minus 4 is minus 16, over negative x raised to negative 6 z cubed. Now firstly, the stray negative will move to the numerator, so I have minus y raised to negative 16 x raised to negative 6 z cubed, right? And if I hate all the negatives, then I'm going to have to move stuff around. I'm going to have to bring the y back down into the denominator, but this time additionally take the x back up, because it's a negative there, right? So this x is going to go back up in the numerator, and this y is going to come back down. So I end up with the negative stays, x raised to 6, right? Because it was a negative in the denominator, so when I push it back up in the numerator, the power becomes positive. Y raised to 16 z cubed. And there you have it. Alright, I think I'm going to run out of space for the next one, so just give me a second. I will quickly get rid of this on my screen, and we'll do one more problem, one last problem. And that would be it for this video. So for my final problem, this is the one that I'd like to do, right? This is a times negative, by the way. Just slightly confusing terminology, I do apologize for that. Anyway, let's look at what's happening in the numerator. We have an expression inside the bracket that is being raised to another exponent. Now, this rule right here tells us that if I have a multiplication and the whole multiplication is raised to a certain power, I can simply distribute the power on the outside among the factors inside. But if I do that here, it's going to be a little complicated. So firstly, what I'm trying to do is I'm trying to simplify certain things if possible. Now, I have to treat this as being in a bracket. I have a negative there and a negative there. So I have a double negative inside of a multiplication. These two negatives will combine and give me a positive. So I can simply get rid of the two negatives, because the multiplication of a negative with another negative gives me a positive. I have an n cubed with no other n, so that's fine. Let me collect the p's together. P squared times p raised to 4 times m raised to negative 3. All of this is obviously being raised to 3, right? And down here this is negative 2 m raised to 4p cubed. Now I have to respect bed mass. Bed mass is the order in which I simplify things. So this stands for brackets, exponentials, division, multiplication, addition, and subtraction, which means I cannot mess around with this. I cannot take the m up or the p's, because all of this up here is under the influence of this exponent. So until I take care of this big exponent, I cannot do the division. So let me set about trying to simplify the exponent. This is going to be n cubed. Inside the bracket, I can simplify because I'm taking care of the whole bracket, right, the b. Only then will I take care of the exponent 3e. This is going to be p raised to, I have the same base, I'm multiplying, so I simply add the exponents. 2 plus 4 is 6, so p raised to 6, m raised to negative 3, whole thing raised to 3, negative 2, m raised to 4p cubed. Now, since I've simplified this a little bit, let me apply this exponent by simply distributing it to every single term inside. And I can do that because I have a multiplication. So this is going to be 9. It's 9 cubed, and I'm going to be raising it to another 3, so it's 9 raised to 3 raised to 3, which will then lead to a multiplication of the exponents. I'm going to have 9, 3 raised to 9, sorry, n raised to 9. Similarly, p raised to 18, it's going to be 6 times 3, and m raised to negative 9. All of this divided by negative 2, m raised to 4p cubed. Let's continue simplification. I'm going to continue down here. This is going to be, I don't see any other n's, so this is just going to be n raised to 9. The p, well, I'm dividing, so this is going to be p raised to 18 minus 3. Why minus? Because I'm dividing, so I need to subtract the exponents. 18 minus 3 is 15. And this is going to be m raised to negative 9 minus 4 again. So we already have a negative 9, we're subtracting a further 4, this is going to be 11, all of this divided by negative 2. Again, I change color just to make it interesting. If I have a straight negative on the denominator, I can push it to the numerator, that's fine. So this is going to be negative n raised to 9, p raised to 15, right? I hate the negative on this, so that's easy. I can simply just push this back down into the denominator and make this 2, m raised to 11. And voila. I think that should be it. So there you have it, a simple introduction into simplifying exponential expressions. The rules are paramount, and the rules are what guide this entire process of simplification. So keep all these rules in mind. These are the rules that will help you simplify any exponential expression.